This is Odum Maths. Please don't forget to subscribe, like, and share this channel on YouTube, TikTok, and Facebook currently. Okay. Maybe in the future, we'll look at Instagram. Okay. Today, I want us to look at logarithm. That has been a brother or a twin brother of indices. Okay. So let's look at this. The number 243 is the same as 3 to the power 5. The number 243 is the same as 3 to the power 5. Okay. Then again, the number 81 is also the same as 3 to the power 4. Then 100 is the same as 10 to the power 2. Okay. So all these, what I've stated here, are in index form or indices form or in indices. Or in exponent form. So 3 to the power 5 is the same as 243 or 243. 3 to the power 4 is 81. 10 to the power 2 is 100. So they are all in index form, or they are in exponent form, or they are in indices. Now let's look at the same thing being written in logarithm form. Okay. So before then, we know 3 to the power 5, this as the base, and this one as index or exponents, and the rest. So we also call it power. Okay. So the same thing applies to this one. The 3 is the base, 10 is the base, 4 is the exponent, 2 is the exponent. Okay. So we say that log, I am starting from this first one. So let me remove or claim okay, so log 243 base 3, because here the base is 3, so base 3 is equal to the power 5, or the exponents. So log 243 base 3, and because 3 is the base here, is equal to the exponents 5. Then we also said 81, which is equal to 3 to the power 4. So this one too, we call this 3 as the base and the 4 as the exponents. So that is going to be log 81. So log this 81, base 3 equals 4. Then the same thing applies to the 100 equal to 10 to the power 2. So that is going to be log 100 base 10 equals the power or the exponent 2. Okay. So in this case, let's say we have a to the power b, which is equal to c. So it means that log c, this c, base a is equal to b, because c is equal to a to the power b. So it's log c base a equals b. So log c base a equals b. Okay, so we are looking at the laws of logarithm. So let me start from, or let's cast our mind to that of indices, laws of indices. The first law says that a to the power m times a to the power n becomes a to the power m plus n. Okay, now let's look at that of logarithm. So for logarithm, the first law says log of, into brackets, m times n with a base a is equal to log m base a plus log n base a. So let's look at it properly. They are multiplying with a common base. So that becomes log of the first one plus log of the second one with the same base. And let's put it in mind that if the base is not written there, it means it is in base 10. Okay, so let's look at how. So this is for indices and this is for logarithm. So in indices, when we have bases multiplying, we add powers. So in logarithm, when you have numbers or the product of two numbers with a common base in logarithm, then here we take log of this plus log of the second one, this with the same base. So let's go to the next one. But before then, let's check that of second law of indices, which says a to the power m divided by a to the power n becomes a to the power m minus n. Okay, now in logarithm, this is going to be log into brackets m divided by n with a common base a, and that is going to be log m base a minus log n base a. Okay, so the first one is in indices, then the second one is in logarithm. Okay, I am mixing them up or writing the two at the same time in the sense that the twin brother of log indices is logarithm. So look at the second law of indices and look at the second law of logarithm. Okay, now let's go to the third one, which is in a bit, if I am to, let's say it's different in a bit, yeah. So that is when you have log of, let's say b with a certain base a, and this b is having a power c. This is going to be, this c should come and multiply, or come in front of this log. So that is c log b base a. Okay. Look at how this is also, we have c coming here to be c log b, then the base is still a. Okay. Now let's look at some 2 or 3 properties in addition to the laws. Then we continue. Now let's look at this scenario. When you have x to the power 1 is the same as x. X to the power is the same as x. Can we change this to logarithm? Yes. So that is log x base x is equal to 1. Because we said 2, 4, 3 is the same as 3 to the power 5. In that case, log 2, 4, 3 base 3 is equal to 5. So looking at this, when I have this x to the power 1 equal to this x, that is log x base x is equal to 1. So it means that log of a number to the base of the same number is 1. So log of 10 billion base 10 billion is 1. Okay, so that's the first property. Now let's go to the second one. Let's say we have a number a to the power 0, and we said it is 1 because any number raised to the power 0 is 1. This is an indices. And can we change this one to logarithm? Yes. So in logarithm, log 1 base a is 0. So log 1 base a is 0. So here a can be any number. So a is any number. A is any number. So log of 1 to any number as base equals 0. Okay. Now let's look at some examples here. Okay. So we are to simplify 1/2 log into brackets 25 over 4 base 10 minus 2 log 4 over 5 base 10 plus log 320 over 125 base 10. Now half or 1/2 log into brackets 25 over 4 base 10 minus 2 log into brackets 4 over 5 base 10 plus log 320 over 125 base 10. Okay. Now we can see that here the third law is being applied. The same applies to this one. So we can say this is log into brackets 25 over 4 to the power 1/2 base 10. Because this should move here. Because the third law says that log b with a certain power c having a base of a can be written as c, this will come here, c log b base a. So when you have this, you can just change it to this one. So that is what you have here. We have it in this form and we've changed it to this one or this one. Okay. Minus, and this is also, we are changing this also. So log 4 over 5 base 10 to the power 2 plus 320 over 125 is the same as 64 over 25. So you can check that on your calculator. Okay, now from here, when we have roots, a is the same as a to the power 1/2. Okay, so it means that 25/4 to the power half is the same as root of this one. So we can say log roots 25/4 base 10, then minus, and this is going to give me log 16/25 in bracket base 10. That is 4 squared is 16 and then 5 squared is 25 plus log into bracket 64/25 base 10. Now this is going to be log 5/2 base 10 because root of this will give me that. Then minus log 16/25 base 10. Let me rewrite this again. So I'm going to interchange them. So this will come here and then minus that. So plus log 64/25 base 10. Then minus log 16/25 also in base 10. Since they have the same base of base 10, so we can say that is log into brackets. Then this one and this one having the same base, add them. So we can say 5/2 times 64/25 over, because of this minus, so divided by, because they have the same base and subtracting, so divided by 16/25. Okay, and that becomes 5 into itself 1, here 5, 2 into itself 1, this side 32. So that is log 32 over 5, 32 over 5, divided by 16/25 and base 10. Okay, so this becomes log into brackets 32/5 divided by 16/25. Okay, so, and they are in base 10. Here we can say that log 32/5 times 25/16. That is, I'm applying the rule of fraction. So I've turned this upside down and changed this to multiplication. Okay, so then base 10. This is going to give me this into itself 1, here 5, here 1, this side 2. So this is log, this and this becomes 10, base 10, and the answer is 1. Okay, so let's get one more example. Without using tables or calculator or calculators, okay, let me add S, or calculator or calculators. Simplify 9 log cube root of 10 base 10 minus 8 log root of 1000 base 10 plus log 1000 base 10 all over 16 log into bracket 1000 to the power 3/4 base 10. Okay, so let's, we said that root of a is the same as a to the power 1/2. So it means that cube root of a is also a to the power 1/3. Okay, so now we can look at this in that nature. So 9 log cube root of 3 base 10, cube root of 10 base 10, sorry, minus 8 log roots 1000 base 10 plus log 1000 base 10 all over 16 log into brackets 1000 base 10, and then this is to the power 3/4. So we can say that this is going to be 9 log 10 to the power 1/3 based on this one. Okay, then base 10 minus, and this is also this is 10 to the power 1/2. So sorry, 1000, so 8 log 1000 to the power 1/2. Okay, and we can even change this one to 10 to the power 3. So 1000 to the power 1/2 becomes 10 to the power 3/2. So this is in effect going to be log 1000, that is 10 to the power 3 over 2, which is the same as 1000 to the power 1 over 2. Then plus log 1000 is the same as 10 to the power 3, so 10 to the power 3, divided by 16 log, this is 1000 to the power 3 over 4, but 1000 is the same as 10 to the power 3. So that is going to be 10 to the power 3 all to the power 3 over 4, which is 9 over 4. So that is 10 to the power 9 over 4. Okay, so I'm going to apply the third law. So this will come and multiply this. That is 1 over 3 times 9 log 10 base 10. Then minus, and here too, we can multiply this to be 3 over 2. So 3 over 2 will come here. So 3 over 2 times 8 log 10 base 10. Plus, this should also come here. That is 3 log 10 base 10. Divided by, now, this is also 3 times 3, 9 over 4. So 9 over 4 will come here. So 9 over 4 times 16 log 10 base 10. Okay. Now, we said log of a number to the base of the same number is 1. So here, this is going to be 1. So 1 over 3 times 9 becomes 3. Times 1 is the same thing minus. This is also 1. 2 into 8 is 4. 4 times 3 is 12. Plus, then this is also 1. Then 3. Over 4 into 16 is 4 times 9 is 36. So then this is 1. Okay. So this is into itself, this is 1 here, 4. 4 times 4 into 16 is 4. 4 times 9 is 36. Okay. Then we add this, and this becomes 6 minus 12. So 6 minus 12 over 36, and that is going to be negative 6 over 36, which is negative 1 over 6. So that is the answer. Okay. So please, thanks for watching. Don't forget to subscribe, like, and share this channel. The name has always been Odu Maths. When you Google it, you get me there. Thank you. Bye.